Well, okay, time for an update on our resistance heating project. As we saw the previous time, the old 70 square just couldn't quite hack it. So, as promised, .300 square. Okay, this stuff is crazy. I got more amps out of this than out of an atomic power plant. And when I first saw this cable and I thought to myself, well, I'm not going to be able to get 2 turns of it onto this trafo, but with the help of some precision instruments, I did achieve that. Now, due to the thickness of it, there is a gap in there between the cable and the actual core, so that my open circuit voltage with this is about 2.4 volts as about 2.7 that we had with the 70 square, because it was basically closer to the core. Now, all that being said, it is some impressive current comes out through this stuff, and for such a heavy cable it's actually very easy to twist it and turn it and do all the various bits that have to be done. But I do think that my transformer here is a bit on the puny side for what I'm doing, but it's free, so for now it'll do. So I'm just after stripping the cable back, which was a chore in itself. I put my crimp terminals on the 2 ends there. So the next thing that I have to do is I have to crimp them. Now, to do that you would typically have a hydraulic crimping tool that would basically crush the crimp onto the copper cable. Now, I have a small one, but that only goes up as far as 70 square, so we're going to have to improvise. And what I'm going to try is my 20-ton hydraulic press. So I'm going to get that set up and we'll see if we can crimp these guys on. Okay, we have hydraulic press comprised of some heavy duty steel section and a 20-ton bottle jack. Now this is built for a different purpose, but as we can see, it's hopefully going to give me, it won't be a perfect crimp, but I think it'll be good enough for what we're trying to do here. So let's see if I can get a good view of that, and I'll start building up some pressure here. As the song says, don't need this pressure on. You can hear it crushing. It's crushing. And the jack is starting to feel it. I think we're starting to get some action. Definitely getting some action here. See if I can get a better bar for this. A bit more. There we go. It's important that we get these crimps as tight as we can, because any kind of resistance in here is going to just cause us problems. especially with so much current flowing. Now I know again this isn't ideal, it should be a hexagonal crimp. Alright, I'm going to go ahead and pump this up to max pressure and come back and we'll do the second one. Okay, we're done. Actually did a very good job on that. I took the jack up to 20 tons and as we can see, not bad for a non-crimp crimp. So the proof of the pudding is we push 2000 amps through this, but so far so good. Alrighty, we got our crimps done, and I've set up a piece of flat on here, and we're going to put some amps through this thing. Now, I have set up a contactor this time, and I have a switch, so okay then. Let's fire the damn thing up. $1,500 amps. 22 amps in, 1500 out. Transformer is humming. Steel is starting to smoke, which is good. Still 1500 amps out, 22 in. $1,500, 22. Still 1500. Ah, the pleasant hum of a 50 Hertz transformer. 21 amps in, 1475 out. I'm going to be a hero here and feel my cable, and it's stone cold. Even up near the crimp the cable is cold, which is a good sign. Oh, steel is starting to glow. We have glow. We have glow plugs. And I got my hand here. Even down here the steel is cold. All the way up here. It's starting to get a little bit warm here. That's where my finger is. So we have glow. We have 1400 amps output, 20 amps input. And we got some serious glowing. Again, my 300 square is just barely warm up here near the steel. Just under 1400 amps output and just under 20 input. And things are seriously starting to heat up here. My steel is starting to form itself, but 1370, 1380 out, 20 in. This is pretty damn interesting, folks. We've got some seriously warm steel here. And I'm going to do my hand test on the 300. 300 is good to go. Just about here now it's a bit warm, alright, but I can keep my hand on it. Steel is quite, oh dear, I think we have to shut down because our steel is getting to ignition temperature. Not good. Okay, now I can put my hand on here. Whoa, this is seriously. I can do some bending action here without any difficulty whatsoever. Now it's the radiated heat from the actual steel that is causing me to have to take my hand away and just get a glove and continue bending. I'm cooling off a little bit there now, but I can still bend. Bend it like Beckham. Okay, well, and let's have a look and see how we're getting on over at Transformerville. Cold, 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 pretty much cold. Now, barely warm up to that crimp, which I would guess is a high resistance point despite my trusty 20-ton press, but no difficulties anyway. A little bit warm around this part of the plan, alright, but again, I'd imagine that's conducted heat actually out of the steel more than it's actually the copper cable getting hot by itself. So let's hit it again. So we're going here and we are on. Actually we've got some magnetic fields going on here. 1400 amps, 20 N. We got serious heat haze coming off this now. Still 1400 amps and 20 N. Now 20 amps in is about a little bit less than 5 kilowatts. Transformers humming away happily, as transformers do. And we're starting to warm things up again over here. Yeah, if you could feel the heat from this, because it's probably going to melt my silly cheapy camera, so may not be the best plan. Okay, I wonder if there's a significant EM field from this thing. Now it's some pretty serious heating here, just 1350 out and about 20 in.